So students, in the last video we saw how the event is a subset of sample space. Now if you look carefully, you will see that all the denominators are the same, and there's a reason. Because the reason why all are the same, it is because all are the elements, the number of elements in the sample space, NFS. And if you if you heard carefully, I am using the same terminologies or the same words which was used when I taught you the chapter sets. Now sample space is a set of all possibilities that is connected to that experiment or to what we are doing. For example, tossing a coin, rolling a die, falling from the chair, and all these things. So the sample space is a set of all possible outcomes, or each element. Now set is what? The collection of elements. Sample space is a collection of elements where each element is one possible outcome. Each element is one possible outcome. So what is the denominator of when we consider probability? These four that you see, it is a number of elements in the sample space, which is quite evident, I understand, but I'm repeating it again to make it clear how all these things are connected with each other. Now what about the numerator? The numerator is connected with the event. How? It is a number of elements in the event set. We saw which are the sets of the event sets we saw in the last video. And if we take the event set, the number of elements in that set is what we put in the numerator. So this is kind of how probability is found. Number of elements in the event set, event is what is asked or what we take, divided by number of elements in the sample space, which is the set of all possible outcomes. Okay, fine. So now let us move on from tossing a coin and let us focus on rolling a dice. Now we know that if we have a dice, there are different ways in which we can, different numbers that we get when we roll it. For example, 1 was what is given, now we get 3, then 2, 1 again, 3 again, 5, 1, 4. There's only one more number that we have not seen, 6, which I don't know when it will come. So anyway, so then possibilities are 1, 2, 3, 4, 5, 6. So there are 6 numbers on a dice. So therefore we have 6 probabilities that can come when we throw a dice. Now suppose I throw another die, one more die, then what happens? There are again 6 possibilities: 2, 3, 4, 5, 6. So depending on, if I am now we, okay, let me just take that off so you can see that 6 faces. So there are 6. So if I'm throwing these 2 die together, like how I tossed 2 coins together, if I'm throwing or rolling these 2 die together, what would I get? I would get a combination of different numbers, which should, for some examples I will show it to you. For example, in this case it is 1 and 4. Now if I roll the dice, roll both of them, let's see what will happen. 3 and 6. Nice. So let us do it again. 6 and 6. Nice. Let us do it again. 3 and 1. So you see, students, that there are different possibilities that we can get when we roll two die together. Now let me take them off. Let us focus at the PPT. So we can, of course, we should write the sample space as a set, but writing them as a set in a straight line would not be that much clear as I represent it now. So that is why I'm representing it like this. So if I'm getting these two faces 1 comma 1, then the answer, I can write the combination as 1 comma 1. If I'm getting these two faces, then it will be 2 comma 1. These three faces, then 3 comma 1. These two faces 4 comma 1. These 5 comma 1, 6 comma 1. And if I'm getting these two faces, then it will be 1 comma 2, 2 comma 2, 3 comma 2, 4 comma 2, and so on. You could just keep going on, and this is what you get. Now students, how many elements are there? This is the sample space of the sample space of the when we throw two die together. Now how many elements are there in this? So how many elements are there in the sample space? That is what the question is. Now we know that this is the sample space, but how many elements are there? 6 into 6, 36. So it's a big sample space, of course. Now let us start with the questions. What is the probability of getting an even sum? So what is an even sum? What does it mean? That means that when we throw two dice, the sum of them should be the same. That is, so it should be even. For example, suppose we take this in 2 comma 2. 2 plus 2 is 4. 3 comma 3. 3 plus 3 is 6. 4 comma 2. 4 plus 2 is 6. 4 comma 1. 4 plus 1 is 5. So that is not included. So you get it. So that is what. So pause the video and try finding the probability of getting an even sum. Now, so let us shade the parts which has. Before shading, we know that the denominator will always be the number of elements in sample space. So it will be 36. Now we need to find the numerator, which is 1 comma 1. Let us shade 1 comma 3, 1 comma 5, which is 6. 1 plus 5, 6. 2 comma 2, 2 plus 3, 4. 2 comma 4, 6. 2 comma 6, which is 8. 3 comma 1, which is 4. 3 comma 3, which is 6. 3 comma 5, which is 8. 4 comma 2, 6. 4 comma 4, 8. 4 comma 6, which is 10. 5 comma 1, which is 6. 5 comma 3, which is 8. 5 comma 5 is 10. 6 comma 2, 8. 6 comma 4, 10. 6 comma 6, 12. So we have these many elements that give us an even sum. Now how many are there? We have 18 of them, exactly the half. So, and we can just simplify and we can write 18 by 36 is 1 by 2, which is our 50%. Okay. Now what about getting an odd sum? What would it be? So odd sum means then I need to change the shaded parts, which would be this. So now again you can count and you will get the numerator as 18. So just the other half. So again 18 by 36 is 1 by 2. So this is also this also, I know that you already studied this, but again I want to show this to you so that it would, you would remind all these things, remember all these things which you studied in the previous classes. So students, what all did we see? We saw about what is sample space, the set of all possible outcomes connected with the experiment. What is experiment? Tossing a die or rolling a die. So whatever you do, whatever is the experiment or the question. Now, then we saw what is the event. What is the event? Which is a specific thing which they are asking. For example, number of heads, even sum, or prime numbers. Whatever is the thing. You can there are countless. There are multiple number of events that you can find, or a teacher can find to give you questions. But anyways, so event, and we saw that event is a subset of sample space and all that. Then we saw that if we take the number of events, elements in the set event, and number of elements in the set sample space, and if we divide them, we get probability of that event. Okay. And as I already said multiple times, we saw that event is a subset of sample space. Now students, this is not necessarily one event. There are multiple events can happen, or multiple events we can make. Now, so we can also call them as event 1, event 2, event 3, event 4. There can be many events, event 5, event 6, event 7, many, depending upon the question and upon the scenario, upon the experiment and all that. Okay. Now, as I already showed you, by shortening it, we call it E1, E2, E3, E4, the events, and the sample space, we just call it S. Okay. Now, look at this. This is something that you studied while in the chapter sets. A union B is A. If A and B are two sets, A union B is equal to A plus B minus A intersection B. Right? Where A intersection B is in brackets, but even if bracket is not there, it is kind of understood because I have put a lot of space in between. Okay. Anyways, now students, so this is something that we studied in the chapter sets, and we already have come to see how sets and probability are all, how the chapter sets, how the topic sets is brought into this topic probability. Now, we studied about Venn diagram, and if we represent this in a Venn diagram, it would be A, and if I have another set B, then there is middle portion, the intersection is what we call A intersection B. If you look carefully, you will see that the colors are matching to what is written in the statement. Now, why are we subtracting this A intersection B? Because we have a set A, then we have another set B. Now this pink part is appearing 2 times. So if we just add them, we will get a increased value of answer, which is wrong. Now we don't want an increased value of answer. So because of that, we cannot add these 2 pinks. So what we do, we subtract one of them, and when we add them, that is when we bring them together, both of them look equal, don't they? So that is why we have to add them and subtract the intersection part. Okay. So this is all known. Now what I want to tell is, students, it is the same when you put probability. Now we know A union B is equal to A plus B minus A intersection B. Similarly, probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. It is the same case when you do probability also. Okay, all the things, or most of the things that you studied in sets is also applicable to with probability. So probability of A union B, or if A and B are 2 events, okay, A and B, if there are two events, we cannot have two sample spaces, of course, it's only one sample space. So when there are multiple sets, they have to be events. So if A and B are two events, doing a union operation on A and B is equal to the probability of event A plus probability of event B minus the intersection of both events. Okay, now what happens if they are disjoint sets? Remember disjoint sets, this is something that we studied in sets. Disjoint sets, that is, their intersection, there is no intersection, that means the intersection is 0. Now we can also consider them as probabilities now. So the probability of intersection is 0, so we can just take them out, 0, it doesn't matter. So in that case, when there is no intersection between events, that is, both events are completely different, you see, the events are different and there is no relationship between each event, then we can call, that means P, we have P of A union B, and that is equal to the sum of P of A plus P of B. Probability of A union B is equal to P of A plus P of B. When these two events are mutually exclusive, and therefore these events are called mutually exclusive events. So it basically means these two events are separate events, they don't have intersection. So such type of events are called mutually exclusive events. So this is just a theory that I'm telling you to make you understand that when the question tells you two events are mutually exclusive, then it means that there is no intersection, there is nothing, that there is no connection between these two events. Okay, now then there is something that I want to talk to you, which is about random experiments. The term random experiments, what does that mean? Now whatever we saw now are all random experiments. For example, tossing a coin, rolling a dice, or even how easy your examination paper or how difficult it can be. Those are all random experiments, While tossing a coin, you can get head or tail. While rolling a dice, you can get 1, 2, 3, 4, 5, 6. While making the question paper, your teacher can make it very difficult, medium, easy, very easy. So, there are all random experiments, and the reason why they are called random experiments are because the the answers are random. You cannot say, okay, this will be the answer. You cannot say that. Or this will be it. Okay, when you toss a coin, it is always head. No, we cannot say that. It could be anything. The outcome could be random. And because the outcome could be random, these type of experiments are called random experiments. Okay. So I think that is enough for this video. I think it is more than enough for this video. The next video will continue.